Why is there a %sign% in the IPv6 address? I am using the Net Framework classes to get the IP addresses for my machine. I have a VirtualBox adapter which has both an IP4 and IP6 address. Using the netcode, I am getting the IP6 address as FA80 71A3 2B00 DDD3 753F %16. Notice the %16 at the end? However, if I query the same usingly, I get the address as FA80 71A3 2B00 DDD3 753F, without the %16. Does the %16 have any special significance? Edit. I just made some more observations about this and they match pretty well with what Stephen Jennings said in his answer. I installed VMware to see what IP6 address it issued. The addresses were clearly, the numbers after % are not some hex representation. I checked all the properties available for a network adapter using ME and found that the numbers are exactly the same as the interface index property of each network adapter. As per MSDN, it uniquely identifies each network adapter and this property was introduced in Vista. What still confused me was why would the IP address class allow you to create an IP address in that format unless it was valid? The answer was provided by Stephen. The number is the scope ID. IP address has a constructor that accepts the address and a scope ID. Oh, and all these three network adapters were linked local. Confirmed it via ipconfig. Cool. That was interesting.
The number after the % is the scoped. IPv6 defines at least 3 reachability scopes for addresses. Globally addressable. This is an IPv6 address given to you by your ISP. It is available to use on the public internet. Link local. This is similar to the 169.254.x.x. Range. It is an address that a computer assigns itself in order to facilitate local communications. These addresses don't get routed around on the public internet because they're not globally unique. Node local. This is an address that identifies the local interface, similar to 127.0.0.1. Basically, this is the address 1. Microsoft has published this article describing IPv6 addressing, which is the least confusing article I found. The article indicates that the presence of a scoped in your address means it is a link local address. You can also tell it is link local because the address begins with FA80. Clear, simply understood information on this topic seems to be rare, so I'm putting the rest of this together based on my best understanding of RFC 4007 and the other information out there. A computer can have multiple linked local addresses, each with a different scope. The scope it indicates which scope the address is for. For example, imagine the scenario of a computer with 2 NICs, each with a linked local address on different networks. If you try to send something to another address beginning with FA80, how will the computer know which NIC to send out on? The scope it appears to be the solution for this.
IPv6 addresses with the prefix FA80:64 are linked local addresses that are constructed by combining that prefix with the hardware address of the network device, 71A3:2B00:DDD3:753F in your example. The analog in IPv4 is 169.254.0.016. Since the prefix is the same for all linked local addresses on a machine, routing might sometimes need to know which interface you are referring to. And that is what the number after the %, called the zone index, specifies. Specifics depend on the operating system. On Windows, %16 is interface number 16. On Linux, for example, you might see something like %F0. Some tools or APIs will consider this zone index unimportant or implicit for their purposes. For example, on Linux the ifconfig tool doesn't show it because it is obvious which interface an address belongs to. But in general it should be taken into account.
The characters after the %, which happen to be numbers in your example, are the zoneid. The zoneid is text that identifies, which helps identify which network card to use. It may look like the name of a network card, or just be a number. Those characters are used to identify a network interface, which people often call a network card. For instance, it can help to determine whether a packet will be using a wired Ethernet card or a wireless Wi-Fi adapter. I'm guessing that you're using Microsoft Windows. It uses numbers as the zoneids. While Microsoft's documentation indicates different types of zoneids, which I discuss later in this answer, for a link local address, in FE80:/64, the zoneid is an interface index of a network card. As a point in comparison, Unix-like systems may use letters after the %sign. For example, FE80:71 A3 2BO DDD3 753 F%S0. In that case, the zoneid, S0, matches the name that the operating system typically uses to identify the network card. In Microsoft Windows, you can get a list of the numeric zoneids by using one of the command lines that check the routing table. I prefer netstatnear, since that also works on other operating systems, but Microsoft Windows also supports routeprint. The resulting output, which gets reported, will likely be over a screen long, so be prepared to scroll back, unless you pipe to more. For example, on my system. You can also see these interface index values, used by many Microsoft Windows versions, with something like config get caption, interface index, ip_address/format column list. People trying that in PowerShell should remember to use backquotes before each comma. Now, here's the tricky part. If you want to ping a remote address, you may need to use the remote system's IP6 address, but the local system's zoneid. So, for example, if I am using computer A and I have a local IP6 address of FE80:1 attached to interface number 14, and I want to ping computer B and it has a local IP6 address of FE80:2 attached to its interface number 16, then this is what I would use. Ping FE80:2%14. So the ping command will send the IP6 packet to the remote IP6 address, FE80:2, which belongs to the remote computer, and will use the interface zone at 14 to do it. The zone at 14 is a number from the system I'm using, not the remote system. So the remote system's address, and the specified zoneid, are coming from different computers. Now, let's look at why this might be necessary. If I want to ping Google's IP6 address, which is 2607:FAB0:408:802:200E at the time I wrote this answer, then the routing table will check which network card handles addresses that start with 2607:FAB0:408:802. The routing table will indicate that none of my network cards are connected directly to a network using addresses that start with 2607:FAB0:408:802, so my computer will end up using a gateway address. If I was connecting to another network that is part of the organization I'm working for, I might have a special gateway address that routes traffic to a private network. In this case, I don't have a more specific gateway, so I will use the IP6 default gateway. That is how IP6 works most of the time, except for link local addresses. This is also how IP4 worked most of the time. I did simplify this example by assuming an IP6 subnet size of /64, since describing the whole process would have made this description even longer. According to RFC 4291 Section 2.8, every computer using IPv6 should assign a linked local address to every network interface. RFC 4291 Section 2.5.6 shows the bits that linked local addresses must start with, which cause the linked local addresses to start with FA80:00:00:00:00:00, although many of those zeros get collapsed to a double colon. The fact that those addresses start with FA80 is also described by RFC 4291 Section 2.4. If you try to ping a remote system, for example, 2607:FAB0:400A:802, the general process is usually to figure out a network or subnet that the address is a part of, which is done by looking at the bits at the start of the address. Then, those bits are used to determine how to route the traffic. However, that process doesn't work for an IPv6 link local address, because every single, operational, active, network interface has a link local address starting with FA80, on a subnet using the subnet prefix /size of /64. If you are on a laptop, you are likely to find that both your Ethernet card and your Wi-Fi adapter are expected to have such an IPv6 address. Now, when you send your ping to FA80:2, you want your computer to send that packet out the right network card. If you have a printer that is connected to a wired network, you don't want to send the traffic out your Wi-Fi card, using a network path/route that won't result in the traffic getting to the printer. And if you are trying to communicate to a wireless device using your Wi-Fi card, you don't want your traffic to go out the Ethernet card. The solution is to have you specify which network device you want the traffic to use. So, that is the purpose of the zoned answer updates. The original version of this answer, which happened to be a rather highly rated answer out of the ones I provided, initially used the term interface identifier instead of zoning. I think that the term interface identifier was simply a term that I had personally made up, and was based on the term interface index, which is used by Microsoft Windows to identify a specific network card. However, the term interface had turned out to be a choice that was less than ideal, since IETF RFC documents have used that term for something else. RFC 1884 IP version 6 addressing architecture uses that phrase for some bits at the end of an IPv6 address. The number of bits seem to vary in some different examples, but this identifier was typically based on the MAC48 address of a network card. RFC 5453 Reserved IPv6 Interface Identifier says, early on, an IPv6 unicast address is composed of two parts, a subnet prefix and an interface identifier, EID, that identifies a unique interface within the subnet prefix. The term zoned comes from RFC 4007, IPv6 Scoped Address Architecture, Section 11, Textual Representation, and, in particular, subsection 11.2, use the term zone_id. While I consider an IETF RFC like that to be most authoritative, I also came across Microsoft Windows Server 2003 documentation, Updates to Understanding IPv6, PDF page 11, printed page 7, which calls this a zone identifier, ID, also known as a scope ID. It gives an example where a zone in the FA80:/64 range is the interface index of the interface attached to the link containing the destination address, but a different example from the FEC0:/48 range where the zone ID is the site ID of the organization site containing the destination address. Upon me stumbling across a different term used by the IETF RFCS, I decided to immediately update this popular answer to be more compliant with such a more official set of standards. Although the initial version was helpful as written, I prefer not to have my documentation differ from how the same phrase was documented by official pre-existing IETF-RFC standards on IPv6 addresses. So this was the main reason for the January 19, 2020 update. Besides updating interface identifier to Zone ID, other minor changes occurred in the January 19, 2020 update. Added the MIC command to get index identifiers in Microsoft Windows. A typo in an address, which said FD80 instead of FE80, was fixed. Minor adjustments, intended to clarify some text just a bit easier. Added hyperlinks to related technical documentation. Actually, such hyperlinks mainly included in this section which describes how various parts of this answer got updated.